The original idea was to have a small box with a Raspberry Pi inside, which would contain a small Pi camera to take pictures, a light sensor which would trigger when exposed to light, and a SIM card to maintain an internet connection and for localization purposes. The client who wants to use our services must buy this box and put it inside a bag. In this prototype, the light sensor and the GPS coordinates have been simulated, whereas the internet connection is maintained through a LAN cable. When a client wants to use our services, first they are assigned a unique user ID, and then they are provided with a device which is activated and is associated to a unique number, that is the bag ID. To make the system scalable, a client can be associated to many devices and a device can be associated to many users. All those informations are stored in the catalog via Postman. Once the user is inserted in our system, they can access all their details using the Telegram interface. The Telegram interface allows the user to see the list of all the bags that they have, and for each bag it allows them to either turn the secure mode on or off, or get the current position of the bag. Once the secure mode is turned on, the device enters a state of high alert where if someone opens the bag in the secure mode, the device takes a picture and sends it to Telegram, who then sends it to the user. The Telegram interface is very flexible since it allows the user to log in and log out from different devices. This can be very helpful in case a user loses their phone but wants to check the information about their bag. They can just give the user ID to the Telegram bot from another phone and be able to access all their details from the other phone. Apart from Telegram, there is also a freeboard interface which allows the user to see the positions, the last refuted position, for all the bags. The catalog is perhaps the most important part of this system. It is first of all responsible of keeping the record of the state of each device module for each bag, whether they are active or inactive. Moreover, it also keeps into account the details regarding all the bags, all the users, and the relationships between them, who owns what and how many. The catalog hosts a REST-based server and is connected to everything in the system using this REST API. The GET methods of the catalog are used by device modules and the servers like Telegram bot and the Freeboard server to retrieve useful information regarding bags and the users that are needed for their functionality. Host methods are used by the system administrator to insert new users and bags into the system, as well as manage the ownership of the bags. It is used by device modules to tell the catalog that they are alive. The put methods are used by the system administrators to change information regarding users, like their names, email addresses, or bags, like their ThingSpeak channels or API keys. It is used by the Telegram bot to add or change the chat ID of a user. The chat ID is explained in the Telegram part of this video. The delete methods are used by the system administrators to remove users or bags that are no longer using the service. Moreover, they are also used by the catalog itself to remove unavailable or offline device modules inside each bag. The Telegram app uses Chat ID to identify users, which is different from the user ID that the Smart Luggage system uses. Therefore, the Telegram bot keeps a dictionary which has a one-to-one relation between Chat ID and user ID. The Telegram bot uses REST API to connect to the catalog to retrieve information regarding users, bags, and the relationships between them. It also uses REST API to retrieve the position of the bags from the ThingSpeak server. The Freeboard server is connected to the catalog using REST API, which it uses to retrieve information about users and their bags. It is also connected to the ThingSpeak server to retrieve coordinates of the bags. The users, in addition to the Telegram bot, can also use Freeboard server to check the positions of their bags. The ThingSpeak server has one channel for each bag. All the channels receive the coordinate informations about the respective bags from the respective location modules. Now, let's look at the modules present inside each device. The secure module is connected to the catalog using REST API, which it uses to retrieve the information about the bag in which it exists. The MQTT functionality of the secure module is explained by this example. Let's take bag 32. It is subscribed to the topic secure 32 to turn the secure mode on or off. And if someone opens the bag in the secure mode, it sends a signal to the light 32 topic to tell the camera module that someone opened the bag and it needs to take a picture. The location module inside each bag is connected to the catalog to retrieve the information about the bag inside which it exists. It is also connected to the ThingSpeak channel where he publishes the information about the coordinates of the bag. To understand the MQTT functionality of the location module, let's take a look at the example of bag number 24. The location module publishes the information about the coordinates of the bag on the ThingSpeak channel only in two conditions. When he receives a message on the topic Secure 24, he publishes the coordinates on the ThingSpeak channel in a periodic way. And whenever he receives a message on the topic GetLock 24, he publishes the coordinates of the bag on the ThingSpeak channel in rapid succession. The camera module is also connected to the catalog to retrieve the information about the bag in which it exists. For the MQTT, again, let's take a look at bag number 32. Whenever the camera module receives a message on the topic light 32, it is triggered to take an image from the camera of the bag and send it on the topic image 32, which is then received by the telegram and is sent to the user. The device modules, secure, location, and camera use a configuration file to know the location of the catalog and the bag ID of their bag. The freeboard uses a configuration file which tells it the location of the catalog. It also uses another configuration file to know where the freeboard itself should be hosted. The catalog itself uses a configuration file to know where it should host itself. It also uses another configuration file to know where the broker is and the token of the Telegram bot. For the demo, 3 computers and 1 Raspberry Pi has been used. The first computer is used to host the catalog and the Telegram bot. This is the console for the catalog. And this is the console for Telegram bot. Now, the Raspberry Pi is responsible for bag number 32. Here we see the location module of the bag. This is the camera module. And this is the secure module. Let's check all the other bags. This computer is responsible for bag number 42. We see the secure and the location module here. And the third computer is responsible for bag number 24. Notice that the computers do not have the camera module. That is because the camera is only attached to the Raspberry Pi. Now, let's check the Telegram interface. We have registered one user who is the owner of all the 3 bags. Here we're going to see the list of all the 3 bags. Let's check bag number 24 first and turn its secure mode on and see what it does. As you can see, the secure mode has been turned on and he's sending his position on the location module on the right. Now, let's do the same for bag number 42. As we can see, the secure mode has been turned on. Now, let's try the rest of the things on bag number 32. Okay, first of all, we turn the secure mode on, and we see the secure mode has been turned on. Now let's turn on the light and see what happens. We will see that the Raspberry Pi is taking the pictures because the secure mode was turned on and the light sensor was triggered, which means the bag was opened while the secure mode was turned on. And here we receive all the images on the Telegram bot. Now, let's try to retrieve the position of bag number 32. There we go. We have received the position of bag number 32.